In this video, we're going to solve a problem about a vertically thrown stone. A stone is thrown vertically upward and returns to Earth in 10 seconds. What was its initial velocity and how high did it go? Let's draw this scenario to help us understand what's happening. We have a stone that starts from the ground, is thrown vertically upward with some initial velocity v0. Then it goes up, reaches its maximum height at some time, and then comes back down, hitting the ground after a total of 10 seconds. To solve this problem, we'll use the kinematics equations for vertical motion under constant acceleration. In the vertical direction with constant gravitational acceleration, we have v equals v0 minus g times t for the velocity equation, and s equals v0 times t minus 1/2 gt squared for the position equation. Our strategy will be to use the given information about the total flight time to find 1. The initial velocity, v0, 2. The maximum height h. Let's start by using symmetry to simplify the problem. First, let's use symmetry to find the time when the stone reaches its maximum height. Since the total flight time is 10 seconds, and the motion is symmetric about the maximum height, the stone reaches its highest point exactly halfway through the total flight time. So, the time to reach maximum height is t up equals t divided by 2, which is 10 divided by 2, which equals 5 seconds. Now, let's find the initial velocity. At the maximum height, the velocity of the stone is 0. This makes sense because, at the highest point, the stone momentarily stops before falling back down. Using our velocity equation, v equals v0 minus g times t, we can write that the velocity at the top is 0. V of t up equals v0 minus g times t up equals 0. Solving for v0, v0 equals g times t up, v0 equals 9.81 meters per second squared times 5 seconds. v0 equals 49.05 meters per second. So our stone was thrown upward with an initial velocity of 49.05 meters per second. Now, let's find the maximum height reached by the stone. We can use the position equation. S equals v0 times t minus 1/2 gt squared. The maximum height h is the position at time t up. H equals v0 times t up minus 1/2 g times t up squared. H equals 49.05 meters per second times 5 seconds minus 1/2 times 9.81 meters per second squared times 5 seconds squared. H equals 245.25 meters minus 122.625 meters. H equals 122.625 meters. So the stone reaches a maximum height of approximately 122.6 meters. Let's summarize our solution for a stone thrown vertically upward that returns to Earth in 10 seconds. 1. The initial velocity v0 is 49.05 meters per second upward. 2. The maximum height h reached by the stone is 122.6 meters. This problem demonstrates how we can use symmetry and kinematics equations to solve vertical motion problems under constant gravitational acceleration. The key insights were finding the time to reach maximum height using symmetry, then using the fact that velocity is 0 at the maximum height to find the initial velocity, and finally calculating the maximum height using the position equation.